Hello everyone, I hope you are doing well. So in this video, we are going to discuss geeks or geeks problem of the day, and today's problem is max sum subarray of size k, and it is an easy level problem. So the problem says that we have been given an array of integers of size n and a number k, and we have to return the maximum sum of a subarray of size k. Right, and they have also mentioned what is a subarray. It is a contiguous part of an array, right? So it can be any contiguous part. Now, this is similar to what we generally do to find maximum sum subarray, but it is much easier than that because now the value of k is also fixed, so the size of the subarray is fixed. Now, whenever you want to perform such operations, whenever you want to find the sum of subarray in this particular range, then what you generally do is we first find the first subarray. So let's say this is the first subarray of size 2, right? So if I can just write it also, this is 100 and then 200, 300 and then 400, right? Now let's say this is my first subarray and I find the answer for it. So in this case it is going to be 300. Now I want to find the next subarray of size 2. How can I find it? What I can do is I can move this pointer one space to the right and move this pointer one space to the right as well. So now the whole subarray will be this one, right? In order to make this change, my sum will increase by 300 and my sum is going to get decreased by 100. Why? Because this particular element was removed, so its value is no longer being considered, and this particular value was added, so now its value is considered, right? So the earlier sum was 300. I need to add 300 to it and subtract 100 from it, so it is essentially going to be 500, and you see that 300 plus 200 is also 500, right? So this is how you basically maintain this whole subarray of size k. So addition is simpler, even multiplication would be simpler because you would multiply this element and then divide with this element. So all these operations which support similar operation like this addition and multiplication, these operations are going to support this type of method, right? Now again, what I would say is this particular method is called the sliding window method. Sliding window. Why? Because you have a window. This is called a window and it is gliding through the whole array, and hence it is called the sliding window algorithm. Right. It is also very popular and used at many places. So this is something that you must absolutely know. Right. Now let us have a look at the code. So the code is very simple. I just initialize my sum and my best answer with 0. Right. And then I'm going to initialize my sum of the first subarray of size k. So from 0 till less than k, I'm adding all the values and I have to consider it as one of the best answers. So I initialize my best with sum as well. Now I start from index k going till less than n and incrementing I. I'm decrementing the I minus kth element. So this will be the element which was just removed from the subarray, and the current element will be the element which was just added to the subarray. Now at the end I can just update my best as maximum of best comma current sum, and at the end I can return my best value. So this would be it for this particular problem. Let me quickly submit this and show you that this particular code works. And obviously the time and space complexity here will be time will be O of n and space will be O of 1 because we are not using any extra space, right? So this you see it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So that is from today. Till the next video drops, keep coding, stay safe, bye bye.